Problem 2.1c in Klein's second edition organic chemistry textbook asks us to draw a Lewis structure for this condensed structure shown here. The book suggests doing it in steps if you're having trouble with this. They suggest in first step 1 to draw out these groups. Groups are shown in parentheses here. And to make a partially condensed structure first before drawing in all the CH bonds and stuff, okay? So we have 3 CH3, CH2 groups, and those are all going to be bonded to a carbon. The carbon atom is here that I'm pointing an arrow to. So more or less, depending on your drawing ability, you just kind of want to draw those in here, okay, connected to that carbon atom. Now be aware the hydrogens are not bonded to carbon, but it's somewhat difficult to draw this, okay, in a partially condensed structure. And so there's the C, and then we have an OH. Now in step 2, what Klein suggests is to now draw in all the C's and H's, okay? So I'll focus on this CH3, CH2 here. So a CH3 is a commonly occurring group in organic chemistry. It's going to be carbon with 3 hydrogens. And a CH2 is going to be an equally common group or subgroup in organic chemistry. And that's going to be bonded to a carbon atom, okay? The carbon atom here, all right? Now that's going to be bonded to another CH3, CH2 group, okay? So I'll position that down here. Here's the CH2, and here's the CH3. Okay, you can see how it first bonds to the CH2 group. So that's why I'm drawing a CH2 group first attached to the carbon there. And so that's another CH3, CH2 group. And then maybe in magenta here, I'll draw another. I know it's going down on the first structure, but I'm going to just draw it up here on the second structure, and that's completely okay, and that's identical. You'll learn more about symmetry and equivalency later in the course. So there's 3 hydrogens on the end carbon, and there's 2 hydrogens on this middle carbon, and it's bonded to the central carbon here, okay? And we'll switch to black here. Now I have just the COH. So I've got the C drawn in, and now I need the O and the H. Now step 3 is to add electrons, and remember that oxygen is divalent, and that's only possible because it has 2 lone pairs of electrons left over to complete its octet. So that's the full Lewis structure there for this molecule. Thanks for watching.